All right, so today we begin Unit 2, which is titled Linear Regression. So let's start by talking about what is linear regression. So linear regression attempts to model the relationship between two different variables by fitting a linear equation or a straight line to the observed data. So linear, keep in mind, is everything about lines. We just reviewed that in Unit 1. And regression is really describing a process for how we show a relationship between two variables, or how we could maybe even use that to predict future values. So if you have a hunch that the data follows a straight trend line or a line trend, linear regression can give you a quick and reasonably accurate result. So for example, I have just a basic scatter plot here, which is going to be our first topic today, where we have our x-axis, which is the number of hours studied. We have our y-axis, which is the test percentage. And then we have these data points where we can see that when we had lower values for the hours studied, we also had lower values on the test percentage side. As the number of hours studied went up, so as we go further along on the x-axis, we see that the data points were higher up on the y-axis than they were before. So the more hours somebody studies, the higher the test percentage that student could expect. So what score can I expect to get if I study for 4 hours? Well, we don't have the numbers of the data here to answer that, but that's the type of thing that we're going to look at throughout this unit, is we're going to take a set of data that's relating two different variables. We are going to look for a trend in the data, like in this case, as students studied longer, their test percentage was higher, to help predict this type of question. What score can I expect to get if I study for 4 hours? And that process of being able to answer that question using data is called linear regression. So throughout this video, if you need to pause the video to write things down, please do that on your own. You can always go back and re-listen to something as well. So we have topic today is called scatter plots. It is day 1 of Unit 2. And our question is, what is a scatter plot? So just some definitions to start out with. First of all, scatter plot. So what is it? It's a graph used to show a possible relationship between two different variables. Here's just a couple of examples. On this first example, we have the scatter plot of weight versus height. Height is down on the x-axis, weight is on the y-axis. And we see we have a lot of different data points here from some set of data. In the second scatter plot, we're looking at beach visitors. We're comparing the average daily temperature along the x-axis. We're comparing the number of visitors at the beach on the y-axis. And again, we just have a random scattering of data points, which is why it's called a scatter plot. The points are scattered. Now on any scatter plot, we have our two different variables. X-axis has the one variable, and the y-axis has the second variable. So on any scatter plot or any set of data, there's something called the independent variable. Now, the independent variable is usually going to be x. And really, for everything that we cover, it is going to be x. So x is the independent variable because the value does not depend on another variable. It's independent of anything else. In our two examples, we see that height was on the x-axis of the first example. So height would be the independent variable. On the second scatter plot, average daily temperature was on the x-axis. So average daily temperature would be the independent variable. Now the other type of variable is called dependent variable. And the dependent variable is the y variable on a set of data. It's the variable whose value depends on the other factor, or the other variable. For example, we're suggesting in this first scatter plot that a person's weight depends on their height. And in the second example, we're assuming that the number of visitors depends on how warm it is outside. So weight is the dependent variable on the first scatter plot, and the number of visitors is the dependent variable in the second scatter plot. The weight depends on the height, and the number of visitors depends on the average daily temperature. So let's take a look at just some sets of data and talk about where we can find the dependent and independent variables. As we mentioned on the previous page, the dependent variable is the one that depends on something else. The dependent variable is often the y variable in a set of data. So when we look at a table like this, where our table is horizontal, the top row typically represents the x variable, and the bottom row typically represents the y variable. So the dependent variable would be the number of visible stars, and the independent variable, or x, would be the humidity as a percent. When we have a table of values, when we have a table of values that's vertical, and we have a left side and a right side, the left side happens to be our inputs, our x values, so that's going to be our independent variable, number of photos taken. The right side typically represents your y's, and that's going to be your dependent variable, the number of photos kept. So the number of photos kept depends on the number of photos that are taken. When it's given to you in graph form, just like we did on the previous page, we saw that our dependent variable is the y variable. So the number of visible stars, if I can get that straightened out, there we go. And then our independent variable is the x, the percent humidity. Okay, so I know it can be a little confusing because those two words are very similar. One just happens to have an IN at the beginning. So one way I also remember this is that on any table of values, there's an input and there's an output. The input is typically the X, the output is typically the Y. So the input is the independent variable and the output is the dependent variable. Just another way to look at it. So here's some more information about just a standard scatter plot, something that we should always make note of when we're reading a scatter plot. The title kind of tells us what the entire graph or scatter plot is talking about. In this case, we're talking about beach visitors. Then we have our two variables. Again, the independent variable is along the x-axis, average daily temperature. The dependent variable is the number of visitors, that's on your y-axis. I want you to notice that we have here, we have evenly spaced values on both the x and y axes. So if we look carefully at the x-axis, average daily temperature, it's going from 80 to 84 to 88 to 92 to 96. So it looks like it's jumping up 4 degrees every time they put a number on there, a label on there. But if you look carefully, there's 2 spaces between every set of numbers. So really, this is counting up by 2s, even though they're only labeling every other one, and it looks like they're counting by 4s. So this first ordered pair, this first dot, would represent 82 degrees Fahrenheit. And then there's 84 degrees Fahrenheit, 86 degrees is on this line, 88 degrees is on this line. So that means that this little dot right here in the middle of the square would be in between 86 and 88, excuse me. So that's probably 87 degrees right here. Now there's this little symbol here that kind of looks like, I like to call it like a little lightning jolt, or like if you look at a heart monitor on like in a hospital, you see this little like toot. And that what that is it's a line break. It's a break in the data. And the reason for that is if we were to go from 0 to 100, counting by 2s, your graph would have to be 50 squares wide or 50 squares long across. And we wouldn't want that because all of our data here for the number of beach visitors starts at 82 degrees, not 0 degrees. But we also don't want to just say, oh, the left side of our graph is 80 degrees, because then things are going to look a little skewed. So we don't want that either. So what we do is if we're creating something like this on our own, we draw a line break and then we start at a number that's lower than our first data value. And then we decide what makes the most sense to count by 1s, 2s, 4s, 5s, 10s, 20s, or whatever. Now on our y-axis, we don't have any breaks in the data, because if we look at our values, we see that our first data point right here, our lowest data point, I should say, is somewhere around maybe 80. I can see it's just a little bit above 75, between 75 and 100. So I'm guessing it's around 80. It might be 81, 82, 85, 86. I don't know exactly. without the data itself, but I can interpret that it's about around 80 to 85. And that goes all the way up to our highest data point up here, which is at 600 visitors at the beach. So it ranged from anywhere about 80 visitors to the beach up to 600 visitors to the beach. So there's no need for a line break there. This individual chose to go by 75s. So you notice it's add 75 every time they go up to the next line. And they did decide to number each one of those instead of every other one. Okay, and that's just a preference. So that's what a scatter plot looks like, and it would include all of these things. Not necessarily needing a break in the data, but certainly it can help with visualizing what your data looks like. So if we're making our own scatter plot, we have here the age in years compared to the weight of, I don't know if these are animals or individuals, we don't have that information. But we're gonna go ahead and make our scatter plot. Let's use blue here. And we're gonna label first our variables. So remember in the table, your independent variable is your input, and that goes along the x-axis. So I'm gonna label, this is my age in years. And now I see that I probably have about 20 different spaces here from the far left-hand side to the far right-hand side. And if I look at my table, my lowest age is half a year. It goes all the way up to 16 years. So I think it's going to make the most sense for me here to just to count by ones. Now, it doesn't mean I necessarily have to label every single one of these squares. I can count and label every, I don't know, maybe every fifth one would be okay, or every other if you want to count by twos. You know what? I think I'll do that. I'll count by twos. So starting at 0 is the far left-hand side. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oops, 13, 14, 15, 16. And even though our data in the table ends at 16, I'm going to go ahead and keep labeling in that same fashion, just every other number. It looks like I'm counting by twos, but really every square counts as 1 year. Now, my y-axis is going to be my dependent variable, and in this case, that is weight. So I'm going to try to write this sideways here. And the weight is being measured in pounds. So I also want to show that on my y-axis. So weight in pounds. And if I look at my weights, it ranges anywhere from a low of 30 or a minimum value of 30 all the way up to a maximum of, 175 is actually the highest. And again, it looks like I have about 20 squares to work with because I think this is a 20 by 20 grid. And I did have exactly 20 squares on the x-axis. So obviously I can't count by ones because otherwise the top of my graph is going to be 20 pounds and I'm not going to be able to plot all my points. If I count by twos, basically doubling it, now the top of my graph is only 40 pounds. That's not going to work either. So I have to figure out what am I going to count by to get 175 to be before I reach the top of my y-axis. And I think in this case, if I count by tens, so 10, 20, 30, I take 20 squares times 10, the top should be 200 pounds. And that'll make everything fit. So basically every square is going to be 10 extra pounds. Now I'm not going to write every single number because I just don't feel like that's a very good use of my time. Instead, I could label every other, like I did the x-axis, or on this one, you know what, I'm just going to label every fifth one, so every 50 pounds. So I'm going to count carefully though, 10, 20, 30, 40. So there's my fifth one, that's 50 pounds. 60, 70, 80, 90. There's my 100 pounds. I count 5 more, 1, 2, 3, 4, 5. That would represent 150 pounds. And then all the way at the top is 200 pounds. Okay, so my graph set up, my scatter plot set up, excuse me. Next, I just want to plot my data. Let's see, I'll use red. I'm going to change this to be a little bit bigger. Let me just test that out. You know, that's not bad, but I think I can go even bigger than that without messing this up. Yeah, you know what? That's pretty good. I like that. Remember plotting points, just like we talked about last week. X first, y second. So you start by going to the right to the x value, and you go straight up to the y value. Since we're only dealing with positives, we don't have to worry about going left or down. So half a year, remember that's not here, this is 1 year. So I'm going to be right in the middle of this box here between 0 and 1 years. And I want to go up about 14 pounds. Well, let's see. I have to count by tens on this side. So have to remember 14 would actually be between 10 and 20, right about there. 5 years is 45 pounds. So I go over the 5 years and I go up to 45. Well, let's see. That line's 40. The next line's 50. So 45 is right in the middle. 14 years is 150 pounds. So I go all the way over the 14 years. I go all the way up to 150 pounds right there. 7 years is 55 pounds. So I go over the 7 years. I go up, let's see, that's 50. The next line would be 60. So 55 is right in the middle. 11 years is 90 pounds. So I started 11 years. I go up to the 9th line, that's 90 pounds. 16 is 175, so 16-year-old. I go up, let's see, that's 150, 160, 170, 180. So 175 is right in between those. And finally, a 2-year-old would weigh 30 pounds. So I go up 3 lines. All right, so there's our data. And I think we could agree that we have a pretty good trend happening here, that as whether it's an animal, a pet, a person, so whatever it is, as this thing gets older, so as the age goes up into higher numbers, we can agree that the weight of whatever this is also increases. So whether it's a dog, probably not a cat, because I don't know many cats that weigh 175 pounds, but certainly could be humans. Could a 16-year-old, so the 10th grader, weigh 175 pounds? Absolutely. Could a 2-year-old weigh 30 pounds? Absolutely. So maybe this is data from humans. I don't know. So that's how you make a scatterplot if you ever have to do it on your own. All right, next, if you're watching this after the live Google Meet lesson, you should now be able to click on the link for your class period, whether you're in 3rd, 5th, 6th, or 7th period, and it'll basically walk you through a step-by-step process for completing the activity today using Desmos activities. If it asks you to sign in using Google, please do. That way your name is recorded, and I can make sure to give you credit for completing today's assignment. That is it for today. If you have any questions, please let me know. Have a great day.